The 1973 Vega with the optional L11 engine features a new two-barrel carburetor, the Holley Model 5210. In this program, we're going to cover the operating principles, overhaul and service procedures, and service adjustments of this carburetor. The tools and equipment you'll need in order to perform the service operations are the carburetor special tools, an overhaul repair kit, a carburetor cleaner, a tachometer, and hand tools. Let's look at some of the unique features found on the Holley 5210. Unlike most two-barrel carburetors, it has both a primary and a secondary venturi. The secondary throttle valve is mechanically operated. It also has a water-heated choke housing. This carburetor has 6 basic systems: the fuel inlet or float system, the idle system, the main metering system, the power enrichment system, the acceleration system, and the choke system. Let's look at the fuel inlet system first. Fuel under pressure from the electrical fuel pump in the tank enters the fuel bowl through the inlet fitting and fuel filter. The float controls the fuel level in the bowl by regulating the fuel inlet needle. The proper fuel level must be maintained in order to assure the proper fuel-air mixture. The fuel bowl is vented into the air cleaner through 2 cast passages in the top of the air horn. A retaining clip is hooked over the float tang and around the needle valve to pull the needle valve downward as the float drops. In operation, the idle system draws fuel from the main well, up the passage and through the primary idle jet. Here it is mixed with air from the primary idle air bleed. The fuel-air mixture then passes the idle transfer holes where additional air can be drawn into the mixture. The mixture moves past the idle mixture screw and is discharged below the primary throttle valve. As the throttle valve is opened, the idle transfer holes are exposed to intake manifold vacuum. The fuel-air mixture will now be discharged from both the idle and the idle transfer holes. As the throttle valve is opened further, the air velocity through the primary venturi increases and causes a low pressure at the main discharge nozzle. This causes the main metering system to begin to operate. Fuel will flow through the main metering jet into the main well. Air is introduced into the fuel in the main well from the air bleed. This mixture is then discharged into the venturi. During heavy load or high-speed operation, a richer fuel-air mixture must be provided in order to obtain the higher engine output. The primary power enrichment system provides this extra fuel. Intake manifold vacuum is applied on one side of the power valve diaphragm. When the manifold vacuum decreases because of increased engine load, the power valve spring overcomes the vacuum and opens the power valve. This allows additional fuel to flow into the primary main metering system. When the engine load decreases, manifold vacuum increases and closes the power valve. The power valve diaphragm, stem, and power valve spring are attached to the air horn. The power valve is located at the bottom of the fuel bowl and is of a 3-piece design. Let's take a look at the operation of the secondary stage of this carburetor. It has 3 systems: a transfer system, a main metering system, and a power enrichment system. As the primary throttle valve opens to approximately 45 degrees, the mechanically operated secondary throttle valve begins to open. As it opens wider, the secondary throttle valve exposes the secondary transfer holes. When the transfer holes are exposed to intake manifold vacuum, fuel is drawn through the secondary idle jet and mixed with air passing through the secondary idle air bleed. This mixture is then discharged at the secondary transfer holes. When the air velocity through the secondary venturi becomes great enough to lower the pressure at the discharge nozzle, the secondary main metering system begins to function. It functions like the primary main metering system, but has different size metering parts. The secondary stage power enrichment system is operated by air velocity. As the secondary throttle reaches the wide open position, the air velocity through the venturi creates a low pressure at the discharge opening. Fuel is then drawn up through the power restriction and mixed with the air from the power air bleed. The fuel-air mixture is then discharged through an opening located in the air horn above the narrow portion of the second venturi. The acceleration system prevents a lag in acceleration when the throttle is opened rapidly. It provides a spray of raw fuel into the primary venturi to cover the brief time lag until the fuel flow can catch up to the increased airflow. When the throttle valves are closed, the pump return spring forces the pump diaphragm back against the cover, unseating the intake check ball and drawing fuel into the pump chamber. When the throttle is opened, fuel is displaced into the discharge passage. This fuel seats the intake check ball and unseats the discharge weight and check ball, spraying fuel into the primary venturi. A close inspection of the discharge nozzle reveals that only the primary passage is drilled. The choke system on this carburetor uses a bimetal thermostatic coil and a vacuum brake diaphragm. The heat source for the thermostatic coil is heat from the engine coolant flowing through the choke water cover. When the engine is cold, the choke valves are closed by the tension of the thermostatic coil. During starting, the choke valves cause a vacuum in the venturi, which makes the main metering system operate, providing a rich mixture. As the engine starts, airflow past the offset choke valves, together with intake manifold vacuum acting on the choke vacuum brake diaphragm, opens the choke valves to the vacuum brake position. As the engine coolant warms up, heat from the choke water housing is transferred to the choke coil, causing it to unwind and allow the choke valve to open fully. A fast idle cam, which is controlled by the choke rod, maintains the idle speed during engine warm-up. When the choke valves are fully opened, the fast idle cam rotates clear of the fast idle adjustment screw. Should the engine become flooded during the starting period, the accelerator can be fully depressed, causing the unloader tang on the throttle shaft to contact the fast idle cam and partially open the choke valves. When new Vegas are shipped by rail, they are stored in a vertical position in specially designed rail cars. This method of shipping is referred to as vertipack. A valve and tube are incorporated in the air horn to drain any fuel in the carburetor bowl into a hose connected to the vapor canister when these cars are placed in the vertical position for shipment. This special hose is not used on Vegas that are shipped in the conventional manner. On these cars, the tube and canister fittings are capped. That covers the principles of operation of the Holley 5210 carburetor. Now let's look at the overhaul and service procedures for the 5210 carburetor. To remove the carburetor from the vehicle, first remove the air cleaner and gasket. Then, disconnect the fuel line, PCV hose, vacuum hoses, and the electrical lead at the idle stop solenoid. On Vegas that were vertipacked, disconnect the vertipack hose at the carburetor. Next, remove the two upper screws from the retainer that secures the choke water and thermostatic cover assembly to the choke housing. Do not loosen the bolt in the center of the cover. As long as this bolt is tight, there will be no coolant loss from the choke water and thermostatic cover assembly. After the two screws have been removed, the water and thermostatic cover assembly can be gently rotated to expose the third screw at the bottom of the retainer. After the three screws have been removed, the choke water and thermostatic cover assembly can be pulled back out of the way. Next, remove the accelerator linkage from the carburetor. After removing the 4 retaining nuts, the carburetor can be lifted from the intake manifold. Be careful when removing the carburetor to avoid draining any of the fuel from the bowl. The presence of dirt or water in the fuel can be the reason for a stumbling or stalling complaint. With the carburetor resting on stands, remove the fuel inlet nut, filter, and spring. Remove the 5 Phillips screws that retain the air horn to the main body of the carburetor. With the air horn raised, the retainer clip can be easily removed from the lower end of the choke rod using needle nose pliers. With the air horn removed, the fuel in the bowl can be examined for the presence of dirt or water. To disassemble the air horn, remove the float shaft, float, and fuel inlet needle. Also, remove the fuel inlet seat and gasket. Next, remove the 3 power valve diaphragm screws, and then remove the diaphragm assembly. After the choke rod has been removed from the air horn, the rod seal will slide out of the slot in the air horn. Next, remove the 3 long screws that secure the choke housing to the carburetor body. Before removing the fast idle link from the choke fast idle lever, notice that the right angle bend in the link is located at the fast idle lever end. Notice also the position of the O-ring that seals the vacuum diaphragm passage to the carburetor main body. Rotate the housing to disconnect the fast idle link from the primary throttle lever. It's not necessary to disassemble the fast idle linkage or the choke housing shaft unless they are physically damaged, dirty, or corroded. The disassembly of these parts is shown in the reminder booklet. To remove the choke vacuum brake diaphragm, remove the 3 cover screws, cover, spring, and diaphragm. It is not necessary to remove the Allen head adjusting screw. Now let's disassemble the carburetor body. To disassemble the accelerator pump, remove the 4 pump cover screws, the pump cover, the diaphragm, and the return spring. Next, remove the pump discharge screw, gaskets and nozzle, weight ball and check ball. Remove the primary high-speed air bleed and the main well tube. Be sure to write down the numbers stamped on the metering parts as they are disassembled, because many of these parts are of a different size, depending on whether they're for the primary or secondary stage. After recording the numbers on the primary high-speed air bleed and main well tube, remove the secondary air bleed and main well tube and record the numbers stamped on them. Now, remove the primary main metering jet and record the part number. Then remove the secondary main metering jet and record its part number. To remove the power valve, use special tool number J10185. This tool is shaped to prevent damage to the power valve. Next, remove the primary idle jet and retainer. The idle jet can now be separated from the screw retainer. Record its part number. Then remove the secondary idle jet, which is on the opposite side of the carburetor body. Since we're overhauling the carburetor, remove the plastic idle limiter cap. Next, turn the idle mixture screw in, counting and recording the exact number of turns required to lightly seat the screw. Then remove the mixture screw and spring. If the point of the idle mixture screw is damaged or grooved, it must be replaced. Remove the secondary operating lever return spring if the carburetor is so equipped. This picture shows its location. Then remove the idle stop solenoid. 2 bolts retain the solenoid to the main body. This particular 5210 carburetor uses a secondary throttle lever return spring that's located on the secondary shaft. Some 5210s could have both types of secondary return springs. It's not necessary to disassemble the primary throttle shaft linkage unless it has been physically damaged or is dirty or corroded and requires servicing. The disassembly of the linkage is shown in the reminder booklet. Next, the carburetor castings and metal parts should be cleaned in an approved carburetor cleaner. Do not place such things as the float, diaphragms, or the electric solenoid in the carburetor cleaner solution. After the cleaning has been completed, rinse the parts in solvent. Wearing eye protection, blow the passages dry with compressed air. Also, inspect all parts for signs of wear. During the reassembly operation, be sure to replace all screws and nuts in their proper locations. Some of the fasteners have U.S. standard threads, while others have metric threads. Thread types and torque specifications are listed in the back of the reminder booklet. To begin the reassembly, reinstall the idle stop solenoid and the secondary operating lever return spring. Now, reinstall and lightly seat the idle mixture screw. Then, back it out exactly the same number of turns as you noted during disassembly. If a new idle mixture screw is being installed, lightly seat the screw and then back it out 4 full turns. Replace all the metering parts, the primary and secondary idle jets, the primary and secondary main well tubes, the high-speed air bleeds, the primary and secondary main metering jets, and the new power valve. The specification sheet in the reminder booklet will be an aid in identifying the primary and secondary parts by their numbers. Next, install the pump discharge check ball and weight ball, the discharge nozzle with a gasket on the top and bottom, and the discharge screw. The discharge weight ball and check ball are the same size. Now, replace the accelerator pump on the main body. Notice that the narrow diameter of the spring is placed against the main body. To reassemble the choke housing, first replace the vacuum brake diaphragm, spring, and cover. Install and tighten the 3 retaining screws. Install the new O-ring at the vacuum passage on the housing. Place the right angle bend in the fast idle link through the fast idle lever at the choke housing. Then place the other end of the link through the throttle lever. Rotate the housing and link and replace the retaining screws to attach the choke housing to the main body. Next, reassemble the air horn assembly. First, reinstall the new power valve diaphragm assembly. Depress the stem while installing the diaphragm screws to prevent damaging the diaphragm. Then install the new fuel inlet needle, seat and gasket, the float and float shaft, and the choke rod and seal. Make the dry float and float drop adjustments before going any further in the assembly. To make the dry float adjustment, place the air horn upside down with the float tang resting lightly on the spring-loaded fuel inlet needle. Use a gauge of the correct size, 420 thousandths of an inch in diameter, or a 27/64 drill to check the distance between the bowl cover and the front edge of the float. Both float kidneys should be at the same height. If they are not, raise the needle valve off its seat. Hold the higher kidney and raise the lower one until they are the same height. To adjust the dry float level, bend the float tang as necessary. This adjustment affects the height of both kidneys. Then, with the air horn held in its normal position, check the float drop. The distance from the bowl cover to the upper front edge of the float should be 1 inch, plus or minus 1/8 of an inch. This distance can be measured with a small ruler or with the special gauge provided in carburetor kit J9789. To adjust the float drop, bend the drop tang on the float assembly. After completing the float adjustment, install the bowl gasket and attach the choke rod to the lever at the choke housing. Then reinstall the air horn to the main body. Finally, install the fuel inlet spring, new filter, gasket, and nut. With the carburetor reassembled, the following service adjustments can be made. To adjust the secondary throttle stop, turn the carburetor over and back out the secondary stop screw until the secondary throttle valve just seats in the bore. Then, turn the secondary stop screw in until it contacts the throttle lever tab. Turning the screw in an additional quarter turn completes the adjustment. Be sure to operate the throttle lever several times to assure that the throttle valves are not sticking in the bores. To make the fast idle cam index adjustment, first place the fast idle screw on the second step of the fast idle cam against the shoulder of the higher first step. Take the slack out of the choke linkage by applying pressure against the choke valve. Use a 140 thousandths gauge or a 9/64 drill to measure the clearance between the downstream edge of the choke valve and the air horn wall. To adjust the fast idle cam index, bend the choke lever tang. When the fast idle cam index is adjusted correctly, the choke unloader is also set. To make the choke vacuum brake adjustment, use a screwdriver to push the diaphragm stem back against the stop. Take the slack out of the linkage and place a 300 thousandths gauge or a 19/64 drill between the downstream edge of the choke valve and the air horn wall. To adjust the clearance, turn the adjustable Allen screw until the clearance is set to the gauge size. Now, replace the carburetor on the engine. Connect the accelerator linkage, fuel line, PCV hose, and the vacuum hoses. Be sure to reinstall the vacuum hoses on the correct fittings. Check the operation of the throttle linkage to make sure that it operates to the full open and closed positions and doesn't bind. Reinstall the choke water and thermostatic cover assembly to the choke housing. Make the choke index setting before tightening the retaining screws. The choke index setting for Vegas with manual transmissions is 1 notch rich. For automatic transmissions, it's 2 notches rich. If the thermostat in the cooling system has been removed or is sticking open, it will result in extended choke operation. This produces a rich idle mixture, causing rough idle, stalling, and poor gas mileage. To make the idle adjustments, the engine must be at normal operating temperature with the choke fully opened and the air cleaner installed. If the car is equipped with air conditioning, it must be turned off. The hose from the fuel tank to the vapor canister should be disconnected, and the distributor vacuum hose should be disconnected and plugged. Using a tachometer, set the idle adjustments to the specifications called out on the vehicle emission control information sticker. If a new idle mixture screw was installed, it must be adjusted to the specified lean drop. After disconnecting the electrical connection of the idle stop solenoid, set the low idle speed to specification. If the Vega has an automatic transmission, place the selector in drive and apply the parking brake when making the idle adjustment. Reconnect the electrical lead to the solenoid and open the throttle momentarily to allow the idle solenoid plunger to extend. Then adjust the screw on the throttle lever to obtain the specified curb idle speed. Next, place the fast idle screw on the high step of the fast idle cam. Adjust the screw to obtain the correct RPM setting. That completes the adjustments. All that needs to be done now is to stop the engine, disconnect the tachometer, reconnect the distributor vacuum hose, and connect the fuel tank hose at the canister.